let's dive into one of the most important concepts in calculus, the chain rule. So you know how to differentiate something like x squared, right? But what about this? You can see we've got one function kind of nested inside another one. This needs a special tool.
And that's where the chain rule comes in. It's built for these things called composite functions.
Yeah, your basic rules just won't cut it. That's why the chain rule is so crucial. The core idea is actually pretty simple. Differentiate the outside, then multiply by the derivative of the inside.
Okay, here's the formal rule. Looks a bit intense, right? But let's break it down.
Let's go back to that first problem and see how this works step by step.
First, we spot the inner and outer functions. Then we just differentiate each piece separately.
Then you just multiply them together and plug the inner function back in. Boom, you're done.
All right, let's try another one. This time we'll throw a trig function into the mix.
Don't worry, the process is exactly the same. Identify the inner and outer, then differentiate. Multiply the results, and that's it. It's a method that works every single time.
Okay, so there's one super common mistake people make. It's really easy to fall for it.
What is it? It's forgetting to multiply by the derivative of the inside function. If you forget that last multiplication step, you get the wrong answer. It makes all the difference. But why does any of this matter in the real world? Well, it's actually huge. It's fundamental in physics and engineering. And get this, it's the engine behind machine learning. Basically, without it, we couldn't compute rates of change for most real-world complex systems. So this one simple rule helps us make sense of incredibly complex systems. What could it help you figure out?